In this video, we're going to continue with our discussion on generating a linear equation using a slope calculated by 2 points and then using the equation that we've been used to, the point slope equation. And the difference here is that in the case of doing 2 points, we have to calculate our slope first using the 2 points. Then we can use the point slope formula. So let's take a look at a graph that we have already seen. This is the graph that we looked at that related the dependent variable pressure to the independent variable temperature. And we had already picked out 2 points when we first went over slope. Point 1 being down here at the lower left at -20, -4, and point 2 being on the y-axis at the value of x0 and value of y at 4. Okay, and our slope calculation is up here, so let's on the upper left. So let's go ahead and fill in what we know. All right, and so what we have is y2 minus y1. The y2 value is 4, and it's going to be 4 minus a -4, okay, from the lower point, point 1, which is going to give us a +8. And then we have the value on point 1 of 0 for x minus a -20. So that gives us a +20, which we said, if you remember, that gives us 2/5, which we could, if we wanted to, round off to 0.4 as a decimal. But for the purposes of calculating our equation, let's just leave it as the fraction 2/5. Okay, so now let's take that value of slope that we have and we're going to create our equation. So the m value is for y equals mx plus b is 2/5. And so now when you're calculating these equations, as we said earlier, you can pick any point you want to do that. But if you can conveniently pick a value or a point that has values that are easy to work with mathematically, by all means do that, because the simpler your numbers are, the less chance of error. So we're going to actually use excuse me, 0.2 for our calculation in the equation. And so we're going to take y1, or let's go ahead and write the general form up first. Y minus y1 equals the slope value times x minus x1. And so using 0.2 as our x and y values, we will have y minus 4 here, okay, equals the slope value, which is 2/5, times x minus the x value at that same point, which turns out to be 0, and you can see how simple that works out. And so then all we have to do is add 4 to both sides of the equation, and we will get y equals 2/5 x plus 4. That's our equation. Notice how the y-intercept, we talked about the y-intercept. If we plug in 0 for x, okay, put in an x equals 0 here, you will have y equals 4, and that gives us the point 0.04, which is our y-intercept, and it actually turns out to also be one of the points we used to calculate our equation. Okay, so and then if you remember from our earlier discussion on slope calculations, we ended up here at the same point in our earlier video. Now let's look at a line that we haven't calculated a slope on and also an equation. And let's just take a look at this line and see if we can pick out 2 points that we can use to calculate the slope and the equation. Well, when you're doing this, as much as you can, you want to pick values or points on the line where you can easily pick out the values, and that's usually where the line crosses a grid point. So right here looks like a grid point that we could use. It crosses the x-axis and a value axis, and it looks like it crosses this, we'll call this one P1, and this one crosses the x value here is -2, 4, 6, -8, okay, and the y value is 0, which is nice, okay, -8, 0, The y value is 0 because it's not above or below the x-axis, and so at the origin the y is equal to 0 and anywhere along the x-axis. Okay, let's see if we can pick out another point that might be convenient. This one looks like it crosses at a grid point or very close to it, so we'll use that. And so the value here for point 2 then is an x value of 2 and a y value of 6, and so this point is going to be 2 and 6. Okay, now we can use this to calculate our slope. Go back over here to the slope calculation, and we have m equals slope equals, okay, so our y value is for point 2 over here is 6, and our y1 value is 0, and for x we have a value of 2, okay, minus a minus 8 down here, so that gives us 6 divided by 2 plus 8, which is 10, and we can reduce that to 3/5. Remember, this is a positive slope, okay, going uphill from left to right. And now we can go ahead and use our equation. Well, which point do we want to use to calculate our equation? Well, again, pick the one that has the easiest mathematics involved when we start adding and subtracting. And since point 1 has a 0 value for y, that might be a natural choice, although it really doesn't make any difference. We would come out with the same equation either way. But let's do that. So we're going to have y minus the y value at that point, which is 0, excuse me, equals 3/5 times x minus the minus 8. Okay, and now we can remove our parentheses and collect some terms, and we get y equals 3/5 times x minus, but that becomes a plus because we've got a minus 8 here, and so 3/5 times 8 would be 20. Let me pause here for a second to cough. Just excuse me a minute. Excuse me a minute. Okay, sorry. 3/5 times 8 would be 24/5. Now, how does that relate? Well, 24/5, we can convert that to 5 into 24, goes 4 times with 4 left over, so it'd be 4 and 4/5. Now, does that seem like a reasonable number? Make that a little bit cleaner looking. 4 and 4/5. And so let's look at the value where we cross the y-axis, which would be our y-intercept, right? Our y-intercept would be at this point right here, okay? There's where it would cross the y-axis, and here's 4, and it looks like it's probably 4/5 of the way up the line, so that's right. So it's 4 and 4/5, which if we plug 0 in for x down here, okay, remember, we would have y equals 24/5 or 4 and 4/5. All right, so there's your calculations for calculating slope and generating an equation starting with 2 points on a line. And that concludes this video.